What's up, guys? It's your boy. I'm just kidding. Alright, so I know I'm behind the day, but here are the notes from 2.8. This one wasn't that bad given the information from the exit tickets, but here's a video just in case you missed class and you didn't want to watch the whole recordings from Microsoft Teams, right? You wanted something a little quicker. So go ahead and pause the video and give this do now a try and let me know what you guys get. Okay, so welcome back. So right here, we're able to see that we are given this information, right? We're given a graph, let's call it f of x. And it's asking us, f of x is greater than 0. What is that interval? Well, let's go ahead and look at this graph. It looks like somewhat of a cubic function, and it has a 0 right here, x equals -2, x equals 2, and x equals 5, right? From here, we can go ahead and see that when f of x is greater than 0, they're talking about the positive part. So let's go ahead and start labeling it. I'm going to go ahead and get the purple, and anything that is below, right, the x-axis. And in case you can see it, this is the x-axis, and this is the y-axis. Anything below the x-axis, so this right here, and between 2 and what we're going to go ahead and say is 5. These in purple is when f of x is less than 0, when f of x is less than 0. And in case you forgot, f of x is the same thing as saying y, when y is 0. Now, we are left over with this other part, and we'll go ahead and put it in baby blue. And this right here is the part that is above the x-axis. So this is when the function is greater than 0. And we can see that from here, from x equals 5 all the way to the right, the y's are going up. So this is also when f of x is greater than 0. So we can go ahead and write these intervals, and we can see that it's asking us when is f of x greater than 0. So we just said it, and I kind of blocked it right there, but it's when x was a -2 all the way to x equals, what was this, 2? So we have an interval from -2 to 2. That is not the only place. We just saw that on this part right here, it is also positive. So from 5, right? From 5, what was that, 6? I was going by 2, so 5, 6. Sorry about that. This should be by 2, so this should be a 6. From 6 to all the way to the right, because you're referring to the x values only. So that's going to be to infinity. Okay. The next one is asking about when f of x is less than 0. And keep in mind that little Pac-Man sign, that inequality sign, is going to go ahead and go towards 0. So that's how I know it's less than 0. So all these purples that have been written, it says from this right here, right, all the way left, the smallest number that I know, so it should be -infinity, right? And it's going up all the way to -2, union from right here from 2 to 6. Okay, so all of that purple is the region where the graph is below the x-axis, where the y's are less than 0. Okay, looking ahead, we can see that both of these homeworks are on our digital notebooks, and they'll be due on Tuesday. Friendly reminder, our exam is on Tuesday as well. And on Monday, we will review. So review and test. So if you've been able to do exit tickets and practice on your independent practice, I'm pretty sure you're going to go ahead and do pretty good. Okay, let's go ahead and begin. So today we're going to be discussing techniques to find out pretty much the same thing we did with our graph, which was a polynomial on x cubed. We can go ahead and see that we're going to do the same, just given without the graph, just the equation. It's going to save us a little bit of time. Okay, these are my expectations for our live lesson, so let's go ahead and skip that. I do have some notes here, so go ahead and pause the video, give this notes, write them down, and these will help us for today. So go ahead and pause the video. Okay. So the same thing we just discussed, when the inequality is pointing to the f of x, that means I'm only caring about the positive numbers. When f of x is less than 0, we only care about the negative numbers. And we want all the numbers, so that's why we talk about the inequality, right? Not the inequality, but the interval. Okay, let's begin. So these are the pretty much the steps I give the students, and it really helps if you go ahead and write them down, and we'll use them right now in a bit. And you're gonna see that this helps you identify the test values, the interval, and in little notation of where it's positive and negative. Okay. Alrighty. So this is my first example. Nothing that bad. I got x plus 3 greater than or equal to 0. So as the step said, right now, write them right here. The first step said, set the factored form, right? Set the factored form and find out what is it, like your x-intercept, and set it equal to 0. So first step, it says x plus 3 is equal to 0. I go ahead and solve for that, minus 3 on both sides, so x equals negative 3. Okay, once you have that, the second step told me to go ahead and put that x value, x-intercept, into a number line. Okay, so I'm going to go ahead and make my number line. Doesn't have to be pretty. Right here is negative 3. And what we're going to go ahead and do from here is we're going to go ahead and find the intervals and test values. So the third step would go ahead and tell us that this would be our pick test values, right? Values. And we're going to go ahead and evaluate them. So I have this x-intercept at x equals negative 3. And I have this region right here to the left. So all the numbers to the left of negative 3, I'm going to go ahead and say that's from negative infinity all the way to negative 3, right? Would you agree? All the numbers to the left of 3. Okay. Now what I want you to know is that this right here has a bar. So therefore it's talking about including 3. Okay. So far so good. The next numbers are going to be the numbers including 3 all the way to the right. So it's going to be the interval, negative 3 in a bracket, all the way to infinity with parentheses. Okay, so far so good. Now we're going to go ahead and pick test values. So it really doesn't matter what number you pick as long as they fall on those intervals. Now what I want you to know is that you only care about the sign after it's been evaluated. So just to go ahead and show that, I'm going to pick up crazy numbers. So let's go ahead and go with negative 100. Yep, negative 100, crazy, right? Because I could have easily picked negative 4, negative 5, and so forth. But just to show you that I don't care about the value that came out, I care about its sign. So for a number bigger than 3, a lot of students would have picked 0, which is perfectly fine. I'm just going to go ahead and pick, I don't know, 200, just to show you that number is going to go ahead and represent the function. Is it above? Is it below? And so forth. Now, there might be a question that says, oh, what actually is ever going to touch? Well, remember, the only way it's going to touch is in the x-intercepts. So let's go ahead and evaluate these test values. So for a value inside here, I got that negative 100, and the value inside this interval, I got 200. Okay, so what I want you to know is the following. We're going to go ahead and test these values. So I'm going to go ahead and evaluate the function at negative 100. And just remember, this was a function that I was given. So I'm going to go ahead and x plus 3, and I'm going to check if I evaluate, is it going to be positive or negative? Okay, so you could probably do this in your head. So negative 100 plus 3, well, a negative number that's very large plus a tiny little positive 3 is still going to give me a negative number. So that's what I want here, a negative. Okay, let's go ahead and try the next one. I'll do it in purple. And I'm testing the value of 200. On the same function x plus 3. And my question is it going to be positive or negative? So we do the same thing. A very large positive number plus a tiny 3, it just makes it more positive, right? I know all of us here can go ahead and say, oh, that's 203. Perfect. But what I care about is it positive or negative? So in this case, it's positive. Okay, now referring to our notes, this symbol right here, the greater than or equal to, when the function is greater than or equal to, I care about whatever is positive. So in this case, my solution is the interval that has all the positive numbers, right? So the sign right here was positive, so, and this was my answer. So this is why I made this little table. You don't have to do it, but it does help out when you are trying to find your final answer. So our solution here is the interval from negative 3 bracket all the way to infinity with the parentheses. Okay, awesome. Go ahead and try this one right here with you. Keep in mind, this one will now have 2x intercepts, but don't worry. You do the same procedure. You set each one equal to 0, right? So you're going to have x minus 4 equals to 0. That's going to give you a number. And x plus 1 equals 0. That's going to give you a number. So go ahead and pause the video. Give these a try, and I'll meet you in a bit. Okay, so solving for that, we got x equals 4. And x equals -1, right? We just solved for x for both terms. So put them from these two gradients, that helps out a lot. And it helps you get your intervals correct. Okay, so I got this right here. And I like to color code my intervals. And I'm gonna see that they both have a little bar. So this right here is including those numbers. So all numbers to the left of -1, that's -infinity all the way to -1 bracket. And I can go ahead and pick a number that exists from there. I'm going to pick -100. Why not? Just to knock out 2 birds with 1 stone. And we are going to go ahead and do the next interval between 1 and -4. I'm sorry, between -1 and 4. So that's going to be bracket because of the bar, -1 all the way to 4. Okay, and our number between there, I'll go with 0. Every time I have negative and positive at the endpoints, there should be a 0. Okay. The next number is going to be all the numbers that are to the right of 4. So from 4 all the way to the right, and the biggest number that I know to the right is infinity. And sure, I'm going to go with, I don't know, 20 as my test value. And all you're going to do, guys, is just evaluate, find out what they equal to. So if I evaluate this function, right, x minus 4, oops, minus 4, that looks even worse. Okay, x minus 4, and then x plus 1. You're going to go ahead and check these test values, and you're going to go ahead and see, is it positive, is it negative, right? And keep in mind, we want what? The positive ones. Keep in mind that sign could change. It could only be greater than or less than, or it could be greater than equal to or less than equal to. So I'm going to go ahead and substitute my first number, which I said is -100. So if I substitute, I got -100 minus 4, -100 plus 1. This right here, I got -100 minus 4, that is negative, negative. And I can't write. And then I have this right here, -100 plus 1. So a big negative number plus a tiny positive 1 is still negative. And then what do we know from algebra 2? Negative times a negative gives me a nice positive. So this right here is a positive. Okay. Let's go ahead and try the next one. The next one that I have is the test value 0. So I'm going to evaluate the function at f of 0. And I'm doing the same thing, 0 minus 4 and 0 plus 1. Okay. So if I go ahead and do this, I get a negative, right? And 0 plus 1 is a positive. Negative times positive is a negative. This right here is negative. Okay, let's go ahead and do the last one. Okay, and I got f of 20, right? Keep in mind your numbers can be different than me. As long as it's between these intervals, right? We will get the same solution. Alrighty, so f of 20, and that's gonna be 20 minus 4, and then 20 plus 1. Okay, so right here, 20 plus 4, that's still a positive number, times 20 plus 1, that is still positive. That gives me a positive. Okay, if you want to go ahead and think about the bigger picture, if you want to be like, Piscina, that's too much work. You can also think about the parent function, guys. You can draw a quick little sketch. You can see where these are all touching the x-axis, right? Let's pretend this is my graph. These are all touching the x-axis like so, and you can look at the degree. The degree here is the quantity of x's that multiply to each other. So the degree is 2. So it should be a quadratic, right? One of these forms, but it is positive. So I'm most likely going to have something like this. So it's probably going to be like so. It's going to be like that. So look how easy that looks like. Like that's pretty much gave me my picture, and I can see, let me get my laser, that from negative infinity all the way to -1, it's going to be above the x-axis. And from 4 to positive infinity is going to be above the x-axis. And we can see that our chart confirmed that from -1 to 4, it is below the x-axis. So that is pretty much the bigger picture of what we want to know. But some students will refer to this being a lot easier, if you will. Okay, so what do we want? We want where it is positive, so right here, and these are the intervals, like so. Okay, so let's go ahead and write them down. So my solution is the interval that has the positive, so it's going to be from -infinity all the way to -1 bracket because of the little bar on the inequality, and then it continues from 4 to infinity. And you could have probably seen it from our graph. So if you have decimals.com opened, you could probably see that our graph will look very, very similar to that. Okay, alrighty, let's go ahead and try this example right here. So this one looks a little bit more intimidating, but I just want you to know that there's different options of seeing this. So let's go ahead and pause the video and give this one a try. Okay. So if you were not able to know how to start, I encourage you to combine like terms. So this right here refers to a 6x, right? But we're usually used to saying a 0 here. But keep in mind, as long as you keep the equation balanced, if you move the 6x to the left, you can still make this work. So let's go ahead and combine like terms just to show you what I mean. So x squared plus 16x, if I move the 6x by subtracting on both sides, I can see that I can indeed combine like terms. Okay. Okay, so 16 minus 6, that is a positive 10x plus 24. Must be greater than 0. Now that right there looks like I can factor it, or I can use the quadratic equation. Okay, so let's go ahead and do the following. So this shouldn't look that bad. I think I have an idea of which one it is, and we can probably see, you guys can probably see it as well. So two numbers that multiply to 24, right? And that add up to positive 10. So I'm thinking about 6 and 4 add up to 10, and they also multiply to 24. So they're both positive, so I'm going to keep these positive. Okay, so far so good. Look, it looks just like the question we just did. We set each one to 0, so x plus 4 equals 0, and x plus 6 equals 0. So x equals -6, x equals -4. So I'm going to go ahead and put them from least to greatest, and we can do the same exact procedure. So go ahead and pause the video right now, give this a try, and you're just trying to do the same thing we just did. So all the numbers to the left of -6 are from -infinity to -6. And notice how this is just a greater than sign, so this is going to be also parentheses. Trying the next one. Between 6 and -4, so you pretty much can know it by now. Between 6 and -4, that pretty much the intervals, all the numbers between, not including -6 or 4. Okay, and we have one more. All the numbers to the right of 4, so all the numbers to the right, so from -4 all the way to infinity. Okay, so it appears I added an extra line here. Alrighty, so the same thing goes. We're gonna go ahead and pick test values. So let me go ahead and pick a test value that is between -infinity and -6. So in class we said like what, -555. And that works, guys, just to get the idea that, hey, this number, -555, is indeed in this interval right here, right? It is a negative, it is between -infinity and -6. Okay, so let's go ahead and evaluate that. So if I evaluate -555, is it going to give me a positive or a negative value? Well, let's give it a try. I encourage you to use a factored form, but you can definitely go back here. But notice how like this right here will be pretty tough. So I'm going to use a factored form, which is x plus 4, x plus 6. Okay, so -555 plus 4 times -555 plus 6. And you just go ahead and see that -555 plus 4, that's still negative. And then this will also be negative. And negative times negative gives me a positive. So this right here was positive. Okay. The next number that I see is, let's go ahead and go with the only number that's there, right? Without going into decimals, I could see is f of -5. And it's going to be -5 plus 4 and -5 plus 6. And you can probably see this a lot easier. This is negative, and this will be positive. And when I multiply those together, I get a negative. Oh, sorry, the number I picked was -5. Okay. Last but not least, a number that exists between -4 and positive infinity. Let's go with, I don't know, 100. So I'm going to go ahead and test 100, and I'm going to go ahead and substitute it into my function, the factored form, 100 plus 4, and then 100 plus 6. And we can probably see that this is a positive number, right? 104, and this right here will be a positive number. Now, I don't need you to solve for this. I don't need you to like freak out and be like, oh snap, I need a calculator, because you really don't. You just need to come up with the idea. Is it a positive number? Is it a negative number? Okay, we're almost done here, and this right here is according to this positive. So let me get my highlighter. We want all the numbers that are greater than. So all the numbers that are greater than are the positive numbers and the intervals. Now I know that I made all of this greater than, but we could easily switch the sign, and now it would be looking for the negatives. So keep that in mind. This is just how I did it for today. Okay, so according to this, our solution is all the values that are greater than 0. Keep in mind, it did not have the equal sign bar, so that's why everything here had parentheses. So our answer should be -infinity to -6, and then a union, right, including -4 and infinity. Okay, awesome. So I got a little meme for us. So yes, I like polynomials to a certain degree, of course. Okay, please don't ban me. Okay, alrighty. The next thing that I want you to see is, how about something like this? Can we factor that? Well, go ahead and pause the video, and I want you to factor this as the best as you can. So hopefully you were able to see that this is an x cubed minus a 16x greater than 0. Now, you probably were like, oh snap, how the heck do I do this? Well, keep in mind, there should be something that we can factor from here. So the first thing is that I want you to go ahead and look at common factors. So what do you see in common? So I see an x on both terms, so I'm going to go ahead and factor that. If I factor out an x from x cubed, I'm left with x squared. And if I factor on x from 16x, I'm left with just 16. Okay, this looks a lot more doable. So this right here is like, looks like a difference of squares. So I can go ahead and factor that. I got the x on the outside, and now I can factor the difference of squares, two numbers that multiply to -16 and add up to 0, right? So I'm going to go ahead and go with +4 and -4 greater than 0. So this is the same thing as saying that, and we can do the exact same thing. I can go ahead and set each one equal to 0, right, to find my x-intercepts. Each factor, I set it equal to, oops, that was not a negative. What did I do? Minus. There you go. What? Perfect. Technical difficulties, guys. X minus 4 equals 0. Alrighty. So pretty much I solve for it. X equals 0. X will equal -4, and x will equal +4. If you solve for x, right? These are all my three x-intercepts. So I'm going to go ahead and leave this -4, 0, and 4. And guys, you're going to go ahead and do the same exact thing. This one will take a little bit more work, but it is the same idea. All the numbers to the left of -4, well, that's negative infinity all the way to -4. Is it going to have a bracket or parentheses? Well, according to this, it's going to have a bracket. Okay, give me a second. Technical difficulties. Alrighty. The next thing is this right here is going to be all the numbers between -4 and 0, right? The next one will be, let me go ahead and do the different colors so we won't get confused. All the numbers between 0 and +4. And last but not least, I got all the numbers to the right of 4. Should be 4 to infinities. This should be a parentheses, right? Okay, so from here, guys, you can go ahead and find the test value. So you can use whichever ones you want. So a number that exists between negative infinity and negative 4, that is negative, let's say, I don't know, any number you want. So negative 100 works for me. A number between negative 4 and 0, negative 1 works. Go ahead and do this right here. From 0 to 4, that is, let's go with 1. And from 4 to infinity, let's go with 100. And all you have to do is test these values. So I'm going to go ahead and do that real quick. So I have this right here. So if I go ahead and use a factor form, I get f of negative 100 was my first one. So negative 100 times negative 100 plus 4 times negative 100 minus 4. So you try to evaluate this. What is this going to be? Well, this is a negative. This will be a negative. This will be a negative. So I got negative times negative times negative. So all of this went positive, and times the negative stayed a negative. It looks like I'm going to be close on space. Okay. The next one is when it's negative 1. So I do the same thing. Negative 1, negative 1 plus 4, negative 1 minus 4. So this is negative. This will be positive, and this right here will be negative. So you can go ahead and do by these two to the left. So negative times positive is negative, and negative times negative is a positive. So this right here is positive. So in class, a lot of students were noticing, hey, there's a pattern. And yes, that really goes back to how the parent function looks like. So I encourage you to look at the parent function every once in a while, and you could probably find out like, oh, cubic looks like this, right? So most likely you will see a pattern. Okay, how about when x equals 1? So let's go ahead and find out when f of 1. Well, that's 1, and then 1 plus 4, and then 1 minus 4. So all of these two were positive. However, this one was negative. So negative times positive is negative. We're probably seeing that pattern right now, right? And last one. Okay. F of 100. So we do the same thing. 100 times 100 plus 4, and then 100 minus 4. So all of these were all positive numbers, so it's going to be a positive just to, okay. Alrighty, so what is this looking for? Well, this is looking for when it is positive. So our answer should be this right here that I'm going to highlight. Everything that is positive. So these two are our answers. Let me write it in black. So our solution should be all numbers in the interval from negative 4 to 0, close brackets, union, brackets 4 to infinity, parentheses. So hopefully this made sense, guys. If not, I'm going to be hosting tutoring on Monday just to go ahead and help you guys out a little bit more. But the idea here comes that you're pretty much not graphing right now, but you're still a little bit still using the graph itself if you look at the parent function. And that could save you quite a bit of work if we're being honest, since that will help you identify the pattern. Keep in mind, this is pretty much a buildup of all that you learned from Algebra 2. So it's pretty dang good to get that practice going. Okay. For independent practice, I didn't give that much work. Just for problems, it could take you like 20 minutes if so. And it's not that bad. So that one will be due on Tuesday. And the exit ticket here, I went ahead and did it as a replacement for one of the rational functions graphing, since that was more difficult. But it's pretty good. Hopefully you give it a try and send it to me on a direct chat. Okay. All right. As always, guys, it has been a pleasure, and thank you.